Hey guys, welcome back. It's Mr. A here again, another section of geometry. Today, we're in chapter 6. We're going to, today begins the first section, 6.1. We're going to talk about angles of polygons. So in a polygon, there's both interior angles and exterior angles, and we're going to talk about those today. All right, so today our objectives, number one, we're going to find and use the sum of the measures of the interior angles of a polygon. And then we're going to find and use the sum of the measures of the exterior angles of a polygon. Okay. All right, here's where we're going to start today. Hey, that's a bunch of polygons. So remember before we talked about different types of polygons. This one has 3 sides. It's a triangle. This one has 4 sides. It's a quadrilateral. 5 sides, 6 sides. Okay. There's more, but this is just to kind of give us an idea of where we start from here. Okay, so this first one here is a triangle. We have 3 sides. Can you remember, and we've talked about this recently here, how many degrees there are in a triangle? If you said 180 degrees, you are correct. So there are 180 degrees. Now this could be any different way here, but this looks like this might be an equilateral triangle. So perhaps this could be 60, 60, and 60. That would make it an equilateral triangle. But the point is 60, 60, and 60 is 180 degrees. Okay, we got that one down. All right. What about some of these other ones though? How in the world could we find out how many degrees are here? Like here, there's 1, 2, 3, 4 angles inside this. What would they add up to be? Okay, here's what we're going to do. We're going to draw what's called a diagonal. All right, so a diagonal is a segment that connects any 2 non-consecutive vertices. So from this vertex right here, if we drew a line to that vertex, it would be a side. If we drew one from that vertex to that vertex, it would be another side. Well, the only other vertex is this one across here. So if I draw a line from this vertex straight across to here, that's considered a diagonal. Okay, so if you look at this now that I've drawn this diagonal from this one vertex across here, just pretend that's a straight line, okay? How many triangles do I have now? Well, if you look at this, hey, there's this little triangle right here, and there's this other triangle over here. I have 2 different triangles. Well, how many degrees are in a triangle? 180. So what that means is in this triangle that I drew right here, these 3 angles would add up to be 180. And in this big triangle here, each of these angles would add up to be 180. And so when we have here, we have 4 sides, and that's a total of what? 360 degrees. Oh, that's interesting. Okay. Hey, that's a pretty cool way of looking at that, Mr. Anderson. Glad you thought of it. I didn't come up with it. But anyway, let's go to the next one here, 5 sides. Now, what we're going to do is we're going to draw a diagonal from this vertex, just from this one vertex to the 2 other vertices that are diagonals. So I'm going to draw one here straight across to that one, and I'm going to draw one from here over that one. Okay, so I'm drawing a diagonal from the same vertex across to these other 2 here. And guess what? Now what do I have? 1, 2, 3 triangles. So I have 180 degrees in those, and I have 180 degrees in these corners, and I have 180 here. And so all together then, that would be what? 180 times 3, or 180 plus 180 plus 180. However you want to say that. 5 sides gives us 540 degrees. You kind of see where we're going with this now? All right, we'll just do one more here. So from this corner here, now we've got what? We can draw, okay. We've got one we can draw there, one we can draw there, and one we can draw there. Okay, so now if you look at this, 1, 2, 3, 4. Now there are 6 sides, but we have what? 4 triangles. So that's 180 for each of those, and so that would be 180 degrees times 4 this time, which would be 720 degrees. Okay, so you can kind of see that depending on the polygon, the degrees are going to be different. But if you notice, what we did here was, when there was one triangle, which is 3 sides, we just did 180 times 1, right? When there were 4 sides, it made 2 triangles, so we did we did 180 times 2. That's how we got the 360. Here we had 3 triangles, so we did what? 180 times 3, because we made 3 triangles when there was 5 sides. Here there are 6. When there were 6 sides, we did 180 times 4. Okay, so notice each time when there's one triangle, we multiplied by 1. For a quadrilateral times 2. Notice each time the thing that we're multiplying by, 3 sides, we're going to multiply by 1. 4 sides, we're multiplying by 2. 5 sides, multiplying by 3. 6 sides, multiplying by 4. So here's what this leads us to, and you'll see in the next screen here as well. All you're going to do is take the number of sides, which we're going to call n, number of sides, and subtract 2, and then we're going to take that times 180. So this is a little formula that we can use instead of going through this every time and drawing all these triangles. All we have to do is, look, if you do triangle 3, put this in here. 3 minus 2 is 1 times 180. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So this is our formula that will tell us how many degrees are total in each polygon, okay? All right, and so that basically that's what this is saying here. What I just kind of showed you is right here, n minus 2 times 180. So whatever the number of sides are in a polygon, we just subtract 2 and then multiply by 180 to figure it out, okay? All right, so example number 1, it says find the sum of the measures of the interior angles of a convex nonagon. By the way, this is very important here. I don't know if I said this really clearly before. It's very, very important that these are interior angles. Okay, this formula is for interior angles. When we get to exterior angles, it'll be something different. But this is only the interior angles. The angles are inside. All right, nonagon is how many? 9, right? So there are 9 sides. Okay, so I don't have to draw this out. I don't have to make all these triangles. All I have to do is say, well, if there are 9 sides, the formula just says 9 sides minus 2, and then I go times 180. That will tell me my answer, right? 9 minus 2 is 7. 7 times 180 is 12. Oh, I didn't mean to do that. 1260 degrees. Okay, 1260 degrees for a nonagon. Okay, but all you're doing is just following that formula. All right, what about finding the measures of the interior? Again, it's interior of an octagon. Okay, how many is octagon? Octagon is 8. So 8 sides. All right, if there are 8 sides, then that means we go in our formula. 8 minus 2 times 180. All right, 8 minus 2 is 6. Sorry, I'll get back to normal in a second. And 6 times 180 is 1080. So 1080 degrees for an octagon. Okay, so you kind of getting the idea there. All we're doing, it's that same formula, just however many sides, subtract 2, and then times 180. All right, well, now here's a little bit different take on it. Now, we're going to use that same concept, but we have to use it maybe a little bit differently. Well, we've done a problem similar to this before with triangles. We might have a triangle and we'd say, hey, you know what? I could add all of these things up to equal 180 because it's a triangle. Well, we can do the same thing. The only thing is we can't make it 180 because it's got 4 sides, right? It's a parallelogram. So a parallelogram is just a certain type of quadrilateral, which means 4 sides. So it has 4 sides. All right, well, why don't we say, hey, you know what? Let's find out how many degrees are supposed to be total in all of these here. Okay, well, how could we do that? Well, with 4 sides, we just do 4 minus 2 times 180. So this is really 2 times 180, which is 360. So there should be 360 degrees all together in here. So if I add all of these up, it will equal 360. So what we do is we just do the same thing like we did with a triangle, except for make it equal to 360. So I'm going to add 5x plus 5x plus 11x plus 4 plus 11x plus 4. And that equals this time 360. Okay, combine all the like terms. So these two together are 10. And then these together are 22. So we got what, 20? 2 and 10 is 32. And then 4 and 4 is 8. Okay. So minus 8. 32x equals 352. And then we're going to divide by 32. And so what we end up with is x equals 11. All right, so that's what x is, but we're trying to find what? The measure of each interior angle. So now all we have to do is we know what x is. We're just going to plug it back in for each one of these. So, well, pretty quickly and easily here we can say, all right, well, let's start with the 5x's, right? Because those are easy. So we got angle R is just going to be what? 5 times 11, which is 55. Angle T, well, guess what? That's the same thing, so that will also be 55. Angle S is 11 times 11 plus 4. That's 121 plus 4, which is 125. And then angle U is actually the same thing as S, and so we can say that's also 125. But see how that works? Same way that we've done before with triangles. It's just that you also have to figure out how many degrees there are in this figure. And in a triangle, we just did 180. Okay? All right, now it's getting more interesting. Hey, it says a mall is designed so that the 5 walkways meet at a food court that's in the shape of a regular pentagon. Find the measure of one of the interior angles of the pentagon. Hey, they don't give us anything here. All they say it's a pentagon. Well, here's the key thing is regular. This word regular. I don't know if you remember that from before, but when we say something is regular, it means all the sides are the same and all the angles are the same. All right, so in this situation here, notice this is the pentagon right here. They're saying that angle, that angle, that angle, that angle, and that angle. Those are the 5 angles that are all the same. Okay, so we know that all those angles are the same, but how can we find out what that is? Well, you know what? How many degrees are there going to be total in a pentagon? That might be a good place to start. Well, pentagon, how many sides is that? If you notice here, it's 1, 2, 3, 4, 5. So let's find how many, plug it into our handy-dandy formula, how many degrees are going to be total in a pentagon. So 5 minus 2 is 3. And then 3 times 180 whoop, would be 540. Okay, so there are 540 degrees total. And what did I just say? That if it's a regular pentagon, they all have to equal each other. So if we know there's 540 degrees total and they all have to be the same, what can I do? All I have to do is take 540 and divide it by 5. Okay, since they all have to be equal, just divide that by 5. And so that comes out to be 108 degrees. So in other words, each one of these angles is 108 degrees. And so if you took 108, 108, 108, 108, 108, altogether they'd equal 540. Okay, so you can do that with anything if it's regular, only if it's regular. If it's a regular heptagon, you can divide by 7. If it's a regular octagon, you can divide by 8, and so forth. Get the idea? All right. How about this one? Let's see, a pottery mold makes bowls that are in the shape of a regular heptagon. Okay, and again, it's a regular heptagon. So we have to find out how many degrees are in a heptagon. Heptagon is 7. So 7 minus 2 times 180, that's 5 times 180. All right, 5 times 180 is 900. So there's 900 degrees total in a heptagon. And so since it's regular, what do? All we do is 900 divided by 7. And it looks like that's going to be, well, with rounding, 128.57. Which looks like would be answer B, and it is 128.57 degrees. Of course, we did have to round that slightly. All right, good. All right, now, this one is probably the hardest one we've got in the whole lesson here. All right, so hang with me here. Pay attention to this one. All right. The measure of an interior angle of a regular polygon is 150. All right, so again, the key thing here is we have a regular polygon. We know this is one of the angles. And since it's regular, it means this is all of the angles, right? Find the number of sides. Ooh, number of sides. We haven't done one like this before. All right, well, what we have to do to solve this is we have to think about a couple different ways that we could find the total number of degrees in this polygon. Since we don't know how many it is, we have to kind of be creative here. So first of all, what's the formula to find the degrees in any polygon? Well, if you remember, it's what? N minus 2 times 180. So I'm going to say this n is what we're going to try to find because that's the number of sides. That's what we're trying to find here, right? The number of sides. So I'm going to say, well, the number of whatever the n is, whatever the number of sides is, if I take it minus 2 and multiply by 180, that's going to give me how many degrees? Well, I have to find, in order to solve for this, somehow I have to make this equal to something. Well, what's another way that I could come up with the total number of degrees in this regular polygon? If there are 150 degrees for each angle, and they're all the same, what could I do? Well, remember, if I had the number of sides, let's say if the number of sides were 3, and each angle was 150, I could do what? 150 times 3. If it was 4 sides, I could do 150 times 4, and so forth. So what I'm going to do is I'm just going to say 150, because that's how many angles, times n, however many sides we have. We just don't know what the number of sides is. But it works because this n is the same as this n. So on this side, I did the regular formula here, n minus 2 times 180. On this side, since it's regular, and again, this only works when it's regular, 150, since they're all 150 degrees times the number of sides. Okay? All right, so now all we have to do is solve this equation. Hardest thing is setting it up. All right, so what I have to do is, first of all, I'm going to distribute the 180. So 180n minus 360. Okay, I just distributed 180 to n and then minus 2. Then I'm going to get the n's together, so I'm going to go, I think I'm going to go, I don't know. Either way, it's, yeah, I'll just do it this way. I feel like I'm doing it backwards, but it'll work. Minus 180n. So I have negative 360 equals negative 30n. Divide by negative 30. And so all we have to do is, and the negatives will cancel here, right? So really it's just going to be 360 divided by 30, which is 12. Guess what? There are 12 sides in this polygon. In order to have 150 degrees for each angle, it has to be 12 sides. Okay? That's a hard one, but oh no, it gave the answer away already. Okay, well, I must have set that up wrong. Oh well. Let's just work it out though. You see it's going to be 10, but it says the measure of an interior angle of, again, a regular polygon is 144. Find the number of sides. So remember what we did, just like before, we say, I'm going to use the formula, n minus 2 times 180, and that will have to equal, since each angle has to be 144, we just take 144 times however many sides there are. Okay, distribute the 180, so 180 n minus 360. By the way, if you haven't figured this out now, we've done this twice when we distributed the 180. What do we get? 180 minus 360 every time. And then, and again, if you want to subtract the 144 to move it over here and then plus 360 so you don't have to deal with the negatives, that's fine. That's what I was contemplating before, just because of the negatives here, but I'm going to do it the same way. So minus 180n, so negative 360 equals 56, negative 56n. Or sorry, oh, 36n. Sorry, I went the wrong way with that. Trying to make that a 3 as much as we can there. And then divide by negative 36. And negatives cancel. 360 divided by 36 equals 10. There you go. So there are 10 sides, and as you saw, the wonderful red ball came in early here, so it already told us the answer. Party pooper. Okay. All right, last thing, I'll try to be quick here. The exterior angles, this is actually going to be easier than what we've just done. If you notice in both of the, here's a triangle. When we talk about the exterior angles, we talk about extending one side out to make this exterior angle. We talked about that before. Extending that side out to make this exterior angle, and then the same thing here. Notice in each of these situations we extend the side going out the same direction. It's going out this way, this way, this way. So you don't make them go out randomly, that you extend them all in the same direction. And if you notice here too, I included these numbers here where you can see 125 and 55 together. That makes 180, okay, which it's supposed to. 60 and 120 makes 180. 65 and 115 makes 180. So you can see these all match up the way they're supposed to, and if you add up the numbers inside here, 60, 55, and 65 all equal 180. So you go, hey, this all works. How many degrees are out there? Well, if I add up 120 plus 125 plus 115, you know what I'm going to get? Boy, 360 degrees. Over here, you can kind of check all these numbers here again if you want to, but again, if I add up the exterior angles, 102, 24, 90, 63, and 81, if I add all those up, you know what I get? 360 degrees. So you know what the rule is for exterior angles? They always add up to be 360. Isn't that a lot easier than what we just did? They're always 360, okay? And so here's two examples that you can kind of see. Yeah, that's how it matches up. It's always 360 as long as you go the same direction drawing your exterior angles out. Just keep going the same direction there, okay? So a couple of quick, and as you can see, here's the official slide that says, yes, 360 degrees, just like I told you. Okay, so here's an example using the exterior angles. Now, there's a lot of angles here, so be careful, okay? When I was practicing this, it kind of took me a few times to get this all right here. So there's a lot of things, so you got to be real careful on how you add this up. But what we're trying to do is, just like we did before when we were doing the interior angles, now we're just adding up all these exterior angles, but it will always equal 360, okay? So I'm going to start here with 5x plus 5 plus 5x plus 4x minus 6 plus 5x minus 5 plus 4x plus 3 plus 6x minus 12 plus 2x plus 3. Okay, so I just worked my way around here. And all those, when they're added together, have to equal 360. All right, so here's the tricky part is we have to add all these up and get this all correctly here. So let's add up the x's here first. All right, so here we've got 5x, that's 10x, plus 4 is 14, plus 5 is 19, plus 4 is 23, 29, and 31. So 31x. Okay, real careful. That's why I underlined those there, because it's sometimes hard to get those all added up correctly. Okay, so 31x. And then when we add up, and I'm going to do this on my calculator here, I think, then we add up the numbers. So we have 5 minus 6 minus 5 plus 3, and then minus 12 and plus 3, and it looks like we come out with minus 12. Oops, equals 360. Okay, so all I do then is just finish solving this equation. Plus 12, 31x equals 372. And then 372 divided by 31 equals 12. All right, so x equals 12. So same thing we did before, add them all up, but you always, for exterior angles, always make them equal 360. All right, last thing. Remember before we talked about regular polygons, but with interior angles? Well, here again, we're talking about a regular decagon, but we're looking for exterior, the measure of an exterior angle. Well, first of all, we have to just figure out how many degrees are going to, exterior degrees are we going to have in a regular decagon? 360. There's always 360 for any, doesn't matter if it's a decagon or a nonagon or a hendecagon or whatever, or a dodecagon. It's always 360. So we know we're going to have a total of 360 degrees. And since this is a decagon, that's what, 10, right? 10 sides. And so all I have to do is what? Take the total of 360 degrees and divide by 10. And so this would be 36 degrees. Each exterior angle in a regular decagon would be 36 degrees. So remember before we had to figure out how many degrees were there for the interior angles and then divide by the number of sides. Now we just always divide it by just 360 divided by the number of sides. That's it. All right, cool. Well, appreciate you being here. Hopefully that all makes a little bit of sense, and hope to see you next time. This is Mr. A signing off. Bye.